In this film number 4 in the series of industrial communication, we will cover Modbus and Modbus Plus. And I use Modbus because it's a good example of a typical serial protocol. And it was introduced back in 1979, and it is quite widespread. And it's easy to implement, few limitations to manufacturers. We'll look into that in a few seconds. And you can use many different physical networks. So Modbus is a layer 7 protocol only, as it's only the application layer. So what you use for the lower layers, that's actually irrelevant to Modbus. So you can use TCP/IP, you can use RS-232, you can use RS-485 and so on. It doesn't really matter. We will come back to that later. It's a request-reply protocol, which means that it's a client-server based. So you request the message and you reply with a message. So this is an example of Modbus on TCP/IP. Then you need the Ethernet protocols, you need the IP protocol and TCP protocol. So all the layers here are covered. While if you use it on, for example, RS-485, you don't use the mid layers here, 3, 4, 5, 6, because what's covered in layer 3 is global addressing. There is no global addressing in a small RS-485 network. There is no need for global addressing either. Layer 4 is how to divide large message into small packages and so on. Layer 5 is how to establish a connection and free the resources when it's done and so on. So there are really things you don't need in order to communicate. So therefore, there is no need for such protocols. But you need something to give local addressing and to define the voltages and bit levels. There is also something called Modbus Plus, which is an alternative. And that is a so-called proprietary protocol. So you need to purchase certain special equipment in order to make this communication work. And then you may use other protocols as well. And you can use a mixed architecture. For example, if you have TCP/IP here as the most important network, the backbone network, you may connect PLCs and HMI. HMI is a human-machine interface, basically a monitor, in order to read and to give touch data input into the network. I/O units, where you connect simple devices, and then you may have a branch down here, which is a 485 network, with a PLC, I/O units, and other devices. But then you need a gateway. You need a protocol translator between the RS-485 and the TCP/IP network here. You may use Modbus Plus, which is the proprietary version. Same here, different devices, but you need a gateway. Then you may use RS-232. Again, you need a gateway, but you can only have one device, because RS-232 is point-to-point. It's not a network structure. When you send a message, the message is generated by the client. In layer 7, you have definitions on how a PDU is supposed to be built. A PDU is a protocol data unit. So it's a data unit from Modbus with a Modbus message. And the message contains a function code and data. We will come back to later what is in this function code and what's in the data. Then it goes down here to layer 2, which is RS-485 in this case. And then you need 485 defines the local addressing and also some error checking. How to find out if the message was received on the other side with an error. Then it goes to the server. And the server could, for example, be a sensor. The client is the main PC, for example, a PLC. The PLC sends a request to be served by data from the sensor, and it goes back. So one message goes here, and a reply comes back. So one message of this format goes over here, and a message with the same format comes back. And the address field, 1 byte, which gives 256 different addresses. But in RS-485, you generally have 32 addresses, but still 1 byte is reserved. Why 247, not 256? Well, there are some reserved addresses. Details. You have function field, which are the different commands that are available in Modbus. You have some data following the command, and here's an example. The command could be set valve to, and the data following it, open. Another, set valve to, closed. And then you have the error check field, which enables the receiver to check if the entire message was okay. So here's an example on how this can be done. The master here requires a state check on 2 coils attached to an I/O unit. Let's go back to this figure here. Let's say that we are here in the RS-485 world. We have an I/O unit, and to that unit we have different sensors and actuators. And these actuators are often called coils because a coil would, for example, generate a magnetic field that closes a valve or opens a valve. So therefore they are actuators. It's another name. A coil is another name for an actuator. The PLC in our case wants to generate a message to an I/O unit, and the message is the I/O unit check 2 coils and see what they are. So the address, this is from the PLC, address 01, this is for the I/O unit 01. The function code is 01, and 01 function code is, if you look in a table, it's check the status of coils. Which coil? Well, it's number 00 and 000A, and how many? 2 coils. So it's 000A and 000B. And then you have the error check code, which is generated by the result from all the others here. The answer back is, hello, this is coil number or I/O unit number 01. You sent me a function code 01. My reply is that I have 1 byte for you, and it's 03. 03, if you translate that into binary, it's 00000011. So the 2 final bits, they are 1, which means that the 2 coils are actually turned on. And then you have some error check code. So this is a typical example of messages that might appear in a Modbus network. Let's study another one. This is again a request from the PLC to the same I/O unit, but now I have function code 05. And if you look at in a table of what function code 05 is, you will see that it is to alter or set the status of a coil. Which one? Yes, you will start with number 000A, that's the only one. And what should the new status be? 0000 means off. So turn it off, please. And this code is generated by the set of bytes here. The reply from the I/O unit is, hello, this is I/O unit 01. You sent me function code 05. You asked me to set coil number A to status off, which I have done. And then the error check code. Note that in this special case, all the data here is the same. The sent data and reply data are the same. Therefore also the error check code is the same, since the error check code is built on basis of what was sent earlier.